does what you expect. So.
I haven't even started beginning. I haven't. I got that handshake, so I'll let him know if it's secure now.
He's right behind you.
Oh, nice.
He's probably got a real shitty password, so you can probably call him that pretty
If it's
quick.
less than 12 characters and no spaces.
Yeah, trying to see. Otherwise, yep, the right idea. Yeah, this is the right.
Hence why we investigated.
All right, welcome everyone. We are always precisely 10 after, now 11 after, close enough to start the meeting. So if you have never been here before, welcome to Sector 67. We do these monthly show and tell kind of meetings, always the first Tuesday of the month. People will give 7-minute talks on projects and things that they're working on and take questions and kind of go from there. So without further ado, I'm going to hand it over to Mr. Jade, who's going to talk to you about his bike that he built.
Hey, what's up, guys? I'm Jade. And, yeah, I built this bike. It's an electric bike, you can see. I don't really know what to talk about up here, but
How did you start?
Huh?
When did this thing start? How long ago?
Started actually over a year ago when I traded a reel-to-reel with a friend, and in exchange we were going to build this bike, and then I finished it. An important concept I learned with building this bike. It's a spot welding concept. You see, all of these batteries, it holds 8 lead acid batteries, and it's all inside the frame. And basically, I had that many batteries because I wanted a decent amount of distance. The bike travels at 30 miles an hour as well. It goes pretty fast. And back to the spot welding concept. I probably spent like 3 times as much time like welding stuff onto this bike and ripping it off because I didn't do any planning. This was like the first project that I've ever really done. Anything this size or this like important to me, kind of like real life use. And I had the moment actually right there on that bike holder thingy. I was like, oh my god, I should take advantage of computers and design it online or on a program or whatever. And yeah, I did that. So all of this sheet metal was cut out by the plasma cutter, and I designed it on Fusion 360 Autodesk. And yeah, welded it on that time, worked great. The pedals only have like 0.5 millimeter of clearance between the batteries. They're actually ratchet strapped in, they're just kind of hanging there. But they should hold like 400 pounds, so we should be good. Hopefully it doesn't fall or anything. Yeah, I tried to reuse as much stuff as I can. It kind of didn't go that way at the beginning. I was wasting a lot of resources actually because I didn't plan or know really what I was doing. Over time, I kind of figured it out though. This was from the recycling bin upstairs. I don't know what it's from, but it holds a controller in it. I actually fried the throttle. I shot 48 volts into it, and it started smoking instantaneously. And I was really worried. I thought I broke the controller. Luckily, that didn't happen though.
What about your fenders?
Fenders, those are built from campaign signs. They're really useful. I took it out for a test ride one day, and water got all over me, and the batteries, and the controller, and everything. That was my next step. But yeah. You guys have any questions?
How much extra money did you put into it?
Yeah, actually, that's a great question. The cost for this bike was about $120, plus 10 for a new throttle. All I got was a Amazon kit. Came with this motor, 48-volt motor, 1,000 watts, the controller, and the throttle. And actually, I just cut all the wires off for everything else because I didn't know what they were used for at the time. Horrible decision. Don't do that. It was really bad. We had to take the controller apart and follow the throttle wires all the way back to see where we need to wire it in. How I originally had it wired up was like, didn't even make any sense. It theoretically shouldn't have even ran, but it did. But yeah, about $120. If I had to buy the batteries though, I think it would have been like an extra 80 maybe, 120. Because there are a lot of batteries in here. I decided to go with lead acid. I had another choice, lithium iron phosphate cells. I would have had to build the battery, but that's way more like costly. You'd have to get PMSs and other sorts of things, and it just takes a lot more time. So for my case, lead acid was the way to go.
How much does it weigh?
Huh?
How much does it weigh?
You know, I should have weighed it, but roughly, I'd assume maybe 150, 200. It's definitely more than I went.
Whoa, really?
Yeah.
It's not that heavy. I bet it's 100 maybe tops.
Really?
Yeah.
Well, I
It's
mean,
only we have scale.
We got some scales here.
that's good. That's a good guess.
Other
Any other questions?
So this is direct drive and not pedal assist, right?
Yeah, no, this is throttle driven. So you don't need to pedal for it to run at all. It's completely driven by the throttle.
But you can pedal still, right?
Yeah, no, I pedal with it all the time. I basically just use it to get up to speed, so you can pedal like 25 miles an hour, like somewhat easily. Yeah, it's quite useful. Before I actually had this design with all the batteries in the frame, I had a piece of wood right here, and 8 of the batteries were just duct taped. It was like this massive wad of duct tape on the back wheel. It was horrible handling. It was, they actually all fell off one day. Let my friend ride it. It wasn't a great idea. That's why I put them in the frame, because when they were all duct taped all over the back, the handling was horrible, and you could like pop a wheelie without even trying. And if you went over any sort of bump, the whole bike was just like boom, 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 boom. It wasn't good.
Sir?
What's up?
How long before you have to be charging? Like how much time do you get out of it for mileage?
Yeah. Since I pedal with it, I'm not sure of the exact range, but I know that I can travel from here to like Monona. MG21 is where I go to school. It's actually how I found this place. And I don't notice a difference with the battery voltage at all. The thing about lead acids, I think, is they don't actually just like go at full speed and then cut off. You kind of feel them running out of voltage, and I don't feel them running out of voltage from here to there. Now it's a couple miles. How many miles? 5? I don't know. Yeah, no, it makes that ride like super easy. It takes like 7 minutes. Easily.
You have to ride down around the lake until you run out of batteries.
I could do that. It's not a bad idea. Not a bad idea at all.
You can take a charger.
Yeah,
You
no,
have to find
definitely.
an outlet.
100%.
Dennis, did you have a question? No.
I was going to say, it couldn't be 4 miles in, because
Yeah.
you're going like 40 or 50 or 60 miles an hour, so it must be about a little over 2.
Yeah.
Any other,
Yeah.
Any other questions?
All right, another question.
All right.
Yeah, of course.
Are you gonna evolve this or is it done?
I think I'm going to move to gasoline.
Gasoline.
No, that's
Kinda like the
You're
opposite.
saying if there's some lithium ion over there, I can sell cheap, right?
that,
True hard.
I could. If you buy me the BMSs, then I could do it. Then I could do it. Because that was actually another thing, was financials and stuff. Basically, I was trying to accomplish like long distance travel somewhat cheaply with the help of somewhat of a
I
motor.
think gas is gonna be better.
Well, yeah, that's what I originally thought too. And you're right as well. The difference is between gas and electric is, I think 1 gallon of gasoline holds like
33 kilowatt hours.
33 kilowatts. Yeah, and that's a lot more than these batteries can. So you can go like 100 miles to the gallon, and you can, I don't know, get a gallon for $2 or whatever.
So how much are you paying to charge it?
About 10 cents a charge. That's what I'm assuming. Not very much at all.
Are you actually paying it or are you just charging it?
No, I'm not. I guess I could. I'm fixing stuff around here and places.
Trade.
You just feel like my presence is the trade. No, I'm just kidding. Yeah. Another thing, actually, was the wiring for this. It's all using really thick cables. These are like 75-watt Anderson plugs. I guess I got to learn how to sell things on Craigslist too, and Facebook Marketplace. It's got a 48-volt headlight charger thingy.
How's that switch work?
That's a 3-way switch, Chris. Took me a long time to wire. A very long time. It broke once too, actually.
What's it do in each of the 3 modes?
There's strobe.
Is it what? You know, I actually got that recommendation. Somebody was going to give me a ton of little LED lights. I was just going to, they wanted me to throw LED lights all over the whole bike. You know,
Always
go,
a good idea.
it'd be kind of cool to see. No, one's off all the time. It's just in the middle. That's where it's at right now. And if you move it down, that's like night setting. So you can like have your light on, see everything in front of you. It's really bright, so it works great. You can consider it to having no light, which I did for a long time. Then if you go all the way up, light turns off, but of course the controllers, or the motor is still like in action, so you can still ride. What's up?
You know, if you want to go all the way to gasoline, why don't you go to an interim step here and do a hybrid with a small gasoline engine and charge your bike?
You need choices.
That would be the only hybrid bike around.
Hybrids are the worst of all worlds.
You raise an interesting point. I could do that.
Bike trailer and put the generator in the trailer.
If I was going to do that, I would definitely do it with a trike. Offer a lot more like storage space. But interesting idea. Not a bad idea either. Yeah, no, that's what I try and so that Insight Honda out here, that green one, that lime one, I was looking into it. And then I kind of learned about like how actually hybrids work. They work by using the electric motor, like getting up to like a high speed, and then the gas engine kicks in and takes the vehicle on. That's what I try to apply to like riding this bike. Is just like getting up to that high speed and then using myself to propel me, and works great.
So what's the gearing like?
That's another great question. When I first got this bike, the gears were practically falling off. There's no way to change gears. You have to do it by hand. If you go backwards, or if you used to go backwards, the chain would just roll off. That's another thing I fixed. The brakes barely worked. This was not a great bike to start this project on. Yeah, I didn't know anything about bikes when I started this project, actually. Mark helped me with the brakes. Thank you.
Oh boy, that might be worse now.
No, really, he did a lot. Yeah, there's only one gear. Keep it on the highest gear. But if you go on the lowest gear as well, it's actually, it feels like you're riding a regular bike. Like it doesn't feel difference in terms of like weight at all, because it is really heavy if you try and pick it up. Actually brought the question up in my head, was this even worth it? Should I have just actually just made like a racing bike, like a really, really light racing bike that's super easy to just bike around? But I took this spot.
You know the answer to that question?
For $150.
$150. I think this was worth it. I gained a lot of knowledge from it. It was a really cool project. It was a really interesting starter project. It was really difficult at the beginning, but after a while, I kind of figured it out. Yeah. Any other questions?
If you're gonna do it again, what would you do different?
Well,
Would you keep the reel to reel?
that's a great point. And probably, or just figured out how I was gonna get rid of it. Made it a little bit more like documented. Should have sold it myself on eBay. Something. That's what I should have done. Question was what? Well, what would I do differently? Oh, yeah. Back to the spot welding concept. Don't just, or I would tell myself, don't throw yourself into something without knowing anything about it. Kind of like research a little bit. Take it slow. Don't lock yourself. Don't weld something on there. Don't just put an absolute shit ton of weld onto something on the permanent frame that you're not even sure is going to work. And I did that. That's when I had that moment. I was like, I need to be using the computer thing. And that helped a lot. That actually was probably how I finished this bike. Spot welding concept. Very important. Don't lock yourself into situations. You're not just going to marry some random person. You're going to date them first. You're going to hang out with them a little bit. You're going to see if you guys are compatible. It's kind of the same idea.
Tom, that's what's wrong with your projects. You don't date them first.
David, throw a knife.
Throwing shade.
How long did this take you?
Oh, this took me, I'm not going to say solely. Chris helped me a lot. Mark helped me a lot. Jim helped me a lot. A lot of people here, Nathan especially, and the internet. Months. Took a long time. Technically, when I started the project, was over a year ago. It started with like 2 boat batteries, just horrendously duct taped on and hooked into a motor, and it was just, that was the beginning. It took a really long time though, probably about 8 to 10 months. And it's totally worth it. It's kind of funny, actually, to look back and just kind of like laugh at all the mistakes and stuff like that.
Do the kids at school think it's cool?
They think it's very cool. Yes, they do. Yeah, no, it's... They do. I think it's interesting. I would too. The school I go to, it's a charter school. It's a project-based school. So people do projects, and they get credit for them. That's how they graduate on. Like this was a school project for me as well, getting credit for it and stuff. There's all sorts of cool projects there. I like it. It's really awesome. MG21. That's what it's called.
All right, thank you, Jade. I believe Jade's selling rides for $10 a piece.
I am selling rides. You can buy it for $2,000.
For an extra $100, I'll give you an insurance rider to go along with it. Ryan, you want to go next?
Yeah, sure. Well, thank you guys. Appreciate it.
Please do. We'll be heading in a very different direction for this presentation, away from electric bicycles onto electric other things.
Say a prayer to the demo gods.
Jesus.
All right. Konagachi, I'm going to start these things up.
Excellent.
Per Sarah's request. See, now you can't see the cute little face on that thing, Sarah.
I'm gonna pass them around. Before I freak everybody out. Alright, so I'm gonna let these things boot up. I'll pass them around after the presentation or during the presentation here. So, to start, who am I? I'm Ryan Zagrodnik. I'm a penetration tester with Synercom. It's not a, I guess, normal title, penetration tester, so I get paid to break into things. So I'm technically a hacker, I guess. Ethical hacker, I like to say. So I don't usually break into things that I'm not authorized to break into because I don't want to end up in a federal prison somewhere. So I began my career as a Windows sysadmin. I've been in InfoSec for the last 10 years. Variety of industries, health, finance, big data, and you can follow me on Twitter. I appreciate it. I don't have a lot of followers, so Pornogacci. What is it? From the website, it's an AI machine learning. In layman's terms, it's a device that's used to capture handshakes from wireless access points, right? So the concept is it automates de-authing clients that are connected to an access point. So one of your devices may or may not lose Wi-Fi connection while these things are running. The next step is it'll capture when you're reconnecting to the Wi-Fi access point. It'll capture that handshake. That handshake contains the password. It'll store that on the device. It won't actually crack the handshake to get the password. I have to offload the handshake to another device and crack it from there. But generally, anything 12 characters or less, no spaces, I can crack in about 2 hours using this laptop. Using our purpose-built password cracker, I can crack those in about a minute. So, if it sounds familiar, a Tamagotchi was a toy during the 90s. It was like it was kind of like these. It came around. You had to feed them and let them go to the bathroom and stuff. So that's kind of Pornogacchi is kind of a play on words for a Tamagotchi. And the reason I'm doing this is for work. I do Wi-Fi penetration tests, so this process manually used to take me a couple hours to capture the handshakes from the access point, where now I walk into a building. I did a bank a few weeks ago. I walk into the bank, it's in my backpack, nobody knows it's in there, and it does my job basically for me. So that's my use case for it. I'm not just driving around in the neighborhood capturing handshakes and logging into your Wi-Fi. But other people are. Legal, I'm not an attorney, so don't take any advice I say as legal advice. Building one of these and attacking access points is a violation of the CFAA, Computer Fraud and Abuse Act. That's the famous one that a lot of the hackers are charged with in most of the crimes, and each state and country has their own laws. So there's the legal jargon, I guess. Legal team maybe put that in there. So build list, it costs less than $100. You can build it, the basic parts, for about $25. And then the extras are the display, USB cable. You probably have one of those lying around from an old cell phone, so you don't necessarily need to buy that. The batteries in these are 1,200 miles, so they'll last about 10 hours, they should. But you can plug them into anything. You can plug them into like a power pack or whatever. And then the case I printed, thanks Chris, shout out. The cases I printed here, so they're about 50 a piece. If anybody's interested, I can provide these links. Maybe I'll post them to the group chat to make it easy. Part of the problem with building one of these is the vendors are either out of it, or I ordered the wrong screen once and I spent 2 hours troubleshooting it, trying to get it to work. So if you want a stupid proof list and you want to order it, let me know and I'll provide these links. But basically, the three that I have up here are about $100 a piece, all said and done. So a pretty cheap build list. Before, the hardware that I'd use during an engagement, would be anywhere from $250 to $500. So definitely a cost savings there. this is kind of the parts list. Some of these, the battery pack up here in the upper left-hand corner, I had to get that from China. You know, it took a few weeks. Same thing with the screen. But I just looked at their day, and they're starting to show up on Amazon in the U.S. So you can get these parts relatively easier now. I don't know about with the coronavirus outbreak.
You can get that easy.
Yes, yeah. So actually, I just got one of the 2 battery packs the other week, and I was like spraying that shit out of it with Lysol, you know, because it got stuck in the port, right? Like, then it got stuck there for some reason. So, yeah, be careful. Careful with your wares. Building it, flashing it, it's pretty easy. You just download the whatever the latest release is. Use this program called Berliner Etcher to flash the SD card, and then you just pop it in and power it up. And there's a few other steps. I don't think I have detail in here in the slides, but it was pretty easy once I got the right screen installed. This is just some pictures of the build put together. I'll start handing these out. We'll just leave that off. Just be careful with this one because the case is off. So they do talk to each other. The faces mean something too. So you'll notice as they go around, the faces will change, and I'll show those in here in a second. So the top here is the battery. The Raspberry Pi Zero is this middle piece, and the screen is the bottom piece. The other side, the power button's up there. That's a charging port. Another charging port here, and then this other port. I think I have here. The data port. So that acts as an Ethernet port. So you can plug that right into your computer. Do a little bit of configuration to talk to it, but still relatively easy. And then you can SSH into it just like a normal computer. So you don't need. I originally thought that I needed like that other piece there on the right is an HDMI, like a mini HDMI or micro HDMI. There's like 1,000 HDMIs now. I originally thought I needed to buy the converter, and then I found out, hey, this is a data port, and then didn't even need to buy it. It still comes in handy if you want to see the screen and troubleshoot it if you're having problems. This is the config. A few things to take note here. I've whitelisted my home, Wi-Fi, and sectors. As it's coming around, you'll see sectors show up on the display. This whitelist keeps it from kicking people off the Wi-Fi. If someone connecting to the Wi-Fi, it'll still capture that handshake, and I'll still be able to crack that password. It's just more of a passive mode than, I guess, an attacking mode. And deauthing, again, deauthing clients on Wi-Fi is technically illegal. The FCC, if they caught you doing it, they wouldn't be happy, but like it's pretty few and far between that they're going to catch you. So again, I'm not a lawyer. Some things to caution. PwnGrid is the system that the creator of this, the handshakes are caught, they're captured, and then uploaded to this thing called PwnGrid. And I was on a client site, and one of the employees noticed I had this Pwnagotchi, and he's like, "Hey, you're not uploading the handshakes to PwnGrid, are you?" And I was like, "I don't think so." I wasn't sure. Luckily, I didn't connect these things to the internet right away. It's kind of a, you have to connect it to the internet. You have to actually edit the config to connect to the internet. So if you're worried about that, in the config, turn PwnGrid off and whitelist. You don't want to obviously send your own whitelist handshakes up to this PwnGrid thing. Like, I don't really know who runs it, you know, but someone out there is collecting all these handshakes, and who knows what they're going to do with them. Just word of caution. This is just more of a breakdown of the display. I won't go over everything on the display, but basically the faces kind of tell the story of what it's doing. You have the number of access points up in the corner, how long it's been up. Down here in the left-hand corner, pwned, is how many networks that it's captured. In the parentheses, the unique captures. Some of the interesting things about this is it uses machine learning and AI. I haven't really dug into it yet. But right below the large face, it detects other Pwnagotchis around it. And I haven't really dug deep into the code yet, but from the creator's website, like, they do talk to each other, and It does have AI brain, I guess, built in where it'll get better at capturing the handshakes. And they work together. Like one knows that it's sniffing, channel 6, so the other one might be on channel 11. So I haven't really messed with that yet. I just kind of built these a few weeks ago. So this is kind of a mock-up for the display. The faces, you'll see them change. This is kind of a layout. There are more. I've seen, like, whenever I see a face I haven't seen before, I try to take a picture of it and look it up. But normally, it'll be looking around. It'll change faces when it's kicking someone from the network. When someone and I don't see it on here. There's a crying face too. When it actually works, it'll cry and say that it lost the handshake. Oh yeah, it is down there. The sad handshake or the sad face. So the faces. I want to do a live demo tonight, but I just didn't get time. So once I capture the handshakes, this is a screenshot of a program called AirCrackNG. This is a CPU-based cracker. This was taken from one of my client's sites. I'm just making sure there's no name on this. So you can see here, this is CPU-based cracking. This one I think I did crack in about 20 minutes. But CPU-based cracking is a lot slower. What I prefer to do, we have a purpose-built password cracker through my employer. It's got 8 1080 Ti's in it. It was about $20,000, and it'll do this same handshake in like a minute. So this is a screenshot from Hashcat. It's a GPU-based cracking utility. Yeah, this was the same handshake, and you can see I'm using a relatively decent word list. You can see it, time estimated 1 minute 18 seconds. So yeah, a lot faster in GPU. However, when I've been experimenting at home with my neighbor's Wi-Fi, I cracked those with my cheaper eBay-based laptop that was like 110 shipped. So like if you've got less than 12 character password, and if it's in my dictionary, I'll crack that like really quick. For example, off the top of my head, one of my neighbors' passwords was pineapple. That was like instant. Another one was the street name plus a number. That one took a little bit longer, but still. Word of advice, like I said, 12 characters. The password cracker has problems with spaces, so put spaces in your password. And yeah, like numbers it'll do right away. So go home tonight and change your Wi-Fi password, because the website also keeps track of how many of these there are in the U.S. right now, and there's like 1,300. And there would be more, but the Pi zeros are hard to get right now because of the coronavirus and all that crap. So cases, you can print the case. There's tons of different models out there, so you just download them and print them. It's pretty easy. Like I said, Chris helped me with that. Otherwise, I would have probably just printed a ball of plastic the first few times that I tried. But they're out there, they're free. The neural network, AI, machine learning, nested if statements. I haven't really dug into it yet. I actually just turned this other guy on yesterday, and it's a message I had never seen before. The neural network is ready. That kind of freaked me out, thinking about Skynet and stuff like that. But yeah, they started talking to each other, and I haven't dug into that yet. So there's also a ton of plugins. There's one where you can have upload your handshakes right to an online hash cracker, and it'll do it for you. Those are free services. However, the people running those, what are they using them for, right? Like, just be cautious uploading stuff there. The one that I have enabled is the memtemp pod. You can see in this other screenshot. So the one on top doesn't have it, and the one down here does. But it'll give you memory usage, CPU, and temp. In the case, I think it's good up to like 70 Celsius, but I've forgot it before running in my pocket, and I was like getting up there. So I try to keep it out in the open air though. We'll see about the cases. Issues. The animal is very picky about syntax. If you have tabs instead of spaces, it will not work. There are tools out there to verify that your YAML is correct. This is the config file. And like I noted here, YAML errors will cause your screen not to function, even though the logs say the screen is fine. So that was another 2-hour rabbit hole that I dug into. On my to-do list, I want to get more into the neural network and machine learning stuff. There's an add-on called PwnMail, where this whole thing is like based on like you can get like internet points. So people are competing with each other to how many handshakes they can capture and stuff. So I haven't really looked into that stuff. The date and time on the devices are wrong right now because for some reason the battery like doesn't power the clock. So there's an add-on for the clock that I want to do, and then I want to look into several of the plugins. So far I built 3 of these. This is the family. I named them, after Internet of Shit things like, crockpots. I guess air fryer and Instapot they're not Wi-Fi enabled, but I still think it's funny. Like, if someone, were actually looking at their logs and saw a device called Instapot was attacking their network, it's the kind of humor I'm into. So I guess that's the end of my presentation. Q&A.
I'd like to preface this question by saying I am not a hacker. So, just so I understand what this is doing, it is capturing the handshakes of devices connected to a Wi-Fi network, the network itself.
Yep.
It's giving that information to you, and because they send an encrypted password across at that point, you're able to crack it.
Yes, yeah. The handshake function of WPA2 is flawed. So if you have a strong password, I'm not going to be able to crack it. There are other attacks I can do, like one of the famous ones called the crack attack, but that's really only for Android devices, and that never works on my engagements. There has been another attack, I can't remember the name of it, that just came out recently, but basically if you're in the market for a Wi-Fi access point, look into WPA3, they're starting to release access points with that. I can't crack those.
You have a very legitimate purpose.
So legitimately, I'm a penetration tester by day. So like, our clients will hire us to come in and do penetration tests of their wireless network. So
they're looking for security.
Exactly, yeah.
Strong enough or not.
Yep. So I go in. Usually the Wi-Fi assessments are announced. When we do pen tests of like external networks and internal networks, they're usually not announced. They're what's called blind. So I don't get any information. With this stuff, like, normally like a client will provide me with their access point IDs. Sometimes I go in and look for them if they want me to, but I have to make sure that I'm not attacking, somebody else, some other tenant's Wi-Fi, right? So, but yeah, that's my legitimate purpose is I go in, attack the access point, I write a report, I hand it to them, and then I hope they fix it.
Kind of like mystery shopper.
A little bit, yeah. Like I done one for a retail store, and I couldn't get to the access point from the main level of the mall. So I actually went in the back area, and I got like between the store and the next store, and there I could attack their Wi-Fi from there. So in the back.
What's the attraction of the Pi Zero?
So the Pi Zero is it's cheap, low power. You can build this on a Pi 3. They have not created a image for Pi 4 yet, but I imagine that they'll probably do that. So, but the Pi Zero is it's small. You can put it in your pocket. People aren't probably going to notice you walking around with a Pi 3 either, but the battery really lasts a long time with the Pi Zeros. So.
Follow up to the legitimate use question. This is very cool, by the way, but I'm missing something. Doesn't the company know its own password? Do they know if it needs to be more digits long?
So you would think that, yeah. I guess that's sort of the thing I reveal after I give them the report, right? I guess I could come in and say, use strong passwords, use WPA3, use radius, use network access control. But a lot of the banks, for example, have regulatory compliance where they're required to have a penetration test once a year. So yeah, the wireless pen tests are usually like a bolt-on thing because would honestly be easier if you just showed me the config to your Wi-Fi, you know, and I'll just be like, you know, thumbs up. 'Cause usually my recommendation is like, have anything besides web, is what I used to say. But now that stuff like this has come out and WPA2 has been easily crackable lately, you know, I've been giving further recommendations, I guess.
So how long a password do you have at home to protect yourself?
So mine is only 8 characters. There's a special character and a lowercase or
I'm
lowercase.
sorry, how many characters?
It's only 8, yeah.
8?
So, yeah, but
They're really complicated.
so the word I use is not in common word list, right? So it's kind of like a lead speak combined, right? And why haven't I changed it? Because I'm lazy, and I'm planning on replacing my wireless setup, you know, in the near future. But changing your password is a pain in the ass, right? Like, you got to do it on all your devices, and it's much easier to put a new access point in with the same old password, and all your devices automatically connect. So yeah, that was a good question.
So on my Apple devices, oftentimes now they let me connect to a Wi-Fi network if one of my other devices is connected to the Wi-Fi network, and they transmit that information to the other device, I guess, somehow.
Yep.
Is that something you can also capture in Blackphone?
So yeah, I mean, since it's automatically set to reconnect, if I send a DAuth packet to one of your devices, it's going to automatically connect. I'll capture that handshake at that time. However, like most of your traffic from your laptop to the access point, you know, even if I decrypt the traffic, the web traffic is still SSL. It's still HTTPS. So majority of your stuff's going to be encrypted anyway.
Yeah.
So it's not a huge worry. If you're going to like FTP into something, you know, or do something that's a clear text protocol, you know, I'd worry about it. But otherwise, these days most of the stuff's encrypted. So generally, I don't spend a lot of time trying to decrypt the traffic when I'm on engagement. It's more of get the password and then write the report.
David, last question.
So, has anybody else got one?
Yeah, I guess, yeah.
There you go. Yeah.
Okay, so would it help if I had 16 of these? Like if you take one of them into a bank, you're still gonna question why you're still there 45 minutes later.
Yes.
But if you took 45 things in,
No.
would you?
I mean, I guess theoretically, yes, it would capture it faster because it's gonna, with more devices, it's gonna be able to deauth more connected devices. But generally, I mean, like for here, once I capture the handshake from Sector, it's Wi-Fi, like it moves on, right? Like it knows that it's captured the handshake and it's not going to deauth anybody else. So.
Oh yeah. Okay.
So yeah, it's yes, the devices help, but like, I mean, I've done one and it's been. I mean,
you're only deauthing just to force them to re-handshake.
Yeah, exactly. Yes. And if a device connects without the deauth, I'll capture that as well. So it doesn't have to attack the Wi-Fi. You can configure it in a passive mode where it's not attacking things.
Yeah, and once he has the handshake, he can take it somewhere else. He doesn't have to sit in the bank lobby. He just needs to deauth one device successfully, capture the handshake, go away,
yep,
and then break the password, then come back, and you can be on their network, then on their internal network.
Oh.
Yeah, so that's the. Yeah, there we go. Light bulbs.
Yeah.
All right, Kermit, you can sneak in.
First step.
Is there reliable deauth for WPA2? I wouldn't know.
Yes. Yeah. There's actually.
Who needs password? We can just shut the whole thing down then. Right?
Yes.
You can
Yeah.
flip the switch and nobody has Wi-Fi anymore.
Yeah.
Yes. Yeah. So there is. I forgot the name of the program, but there is stuff out there that will deauth everybody.
I had one like 6 years ago and it was nasty. WPA came out and it stopped working.
In my youth, I was a little bit, I guess, more of an asshole, and yeah, like I you know, you can go into a coffee shop and deauth everybody, and you can just watch people just getting pissed off. Yeah. So, but then it's nice because then you've got all the Wi-Fi to yourself. So. Yeah.
So how much does it sell?
So you can build one of these, like I guess you know, I'd say without a case and all the battery and all that stuff for like $25. Yeah.
The catch is this device can only work so quickly. So we had a whole room full of people. It can deauth someone, and your network will drop for a second, and then you'll automatically reconnect while that device moves to another target, and it'll continue to evolve. And so you need something that can really massively dump crap to block it. I will say I played with Aircrack when it first came out. I have not done this in years, but these tools have been around for probably 14 years now, I bet.
Yeah, I've got a cheat sheet, but yeah, Aircrack is what I use. When I'm manually doing it, I'll use Aircrack to do deauth. And it's like
you used to have to buy a certain hardware device that supported
that's
these
true.
packets. And
It has
now
to
you
do
can
the,
do it with anything. So
the device has to support packet injection, and there are like Wi-Fi, USB things you can buy for it. But that was the Pi 3 and Pi 4 out of the box. I believe their Wi-Fi chips can do packet injection for deauth. But yeah, you can't do it if the chip doesn't support it, you can't do it. So
everyone go home sad that anyone can use your Wi-Fi network, or be like us and have a terrible password.
Go home and change. Yeah, just change your passwords.
I turned off WPA too because it was too slow.
That's
I've been open.
it's bad advice. Don't listen to that. So.
All right, Scott.
All right,
thanks.
thanks.
Thanks, man. Lights back on, Sarah.
Okay.
You gotta be able to see this thing spin, or you can't see how your arm can get thrown off.
Oh my God, does this come as a training video as well?
This is gonna be impossible. Keep your fingers away from the shots. This is our new ice cream machine. So my name's Scott. I'm a member here.
And maybe 8 months ago, Chris approached us with the project.
I believe this exact video, in fact.
Oh yeah.
You want to play it first?
This video, yeah, go ahead.
2.5 minutes of your time.
Oh no, it'll be shorter than that.
We'll just see the highlights of the video, which, we're doing construction to bring this place from a warehouse to a educational facility, and that requires insulating the walls, building walls. And so Chris said, well, we still have a lot of walls to insulate, and we've kind of used up our free rentals from the place where we bought the insulation, so we were looking to fabricate an insulation blowing machine. Yeah. You two seem like just the two suckers taking the project.
I didn't say it exactly like that. I think I used different words.
No, it's the subtext.
Similar.
So, that sounded interesting, and we took it on. So, Luke and I have been working together on this project for, on and off for that amount of time. Basically, one of the things I love about this space is sort of the intergenerational nature of it, the learning nature of it. And so, I'm a results-oriented builder, and so I've been trying to walk the path of going walking the path of Luke on this project as a project for the two of us to do together and learn. So, I don't know if you want to talk about some aspects of the machine and how we built it and what we did.
I mean, yeah, so basically we started out by watching this video and trying to see how they built theirs, and then we basically tried to copy it as closely as we could without any actual instructions. And so, yeah.
There's a member named Tom who works for Google. He did some work to actually measure the sprocket ratios and stuff like that. And so he did a layout from the video, yeah.
Then we ran a stopwatch to be able to time the rotations of the tines to figure out the RPMs.
So you reverse engineered from a video.
Yes.
Yeah.
But the video has a frame rate that's gonna throw that way off.
It's shot in real time, and you know what the video frame rate is because YouTube can tell you.
Oh, okay.
So yeah, you can figure out how fast it's spinning.
Okay.
So it was a very interesting project. We had to do a lot of different things. There's an electric motor with a control. We used some controls we had here and the motor we had here. You want to walk up through the drivetrain from the motor up through all the
Yeah, sure. So the drivetrain is on this side.
Can you turn it so we can see?
Yeah.
Cool.
So this is what we did first. This part's connected to the motor, this one down here, and there's all the chain is connected to the three blades, or like shafts with blades attached to them. And so when we turn that on, all those will start spinning and basically just that's to break up the insulation. And so that's the purpose of this gear train, and then with the
Here we have the fabric
Yeah.
that.
then with the electric box we can change the speed and also the direction of it if we want to. Also, these are attached with bolts so we can move them side to side to tension this or loosen it.
So what's the insulation?
Cows.
Yeah, we start with cows. It's bales of cellulose insulation, so it comes tight packed in basically shrink wrapped bales. We could bring one down from upstairs if you want to see.
Let Jim see one.
The idea is it's supposed to be about big enough so you could drop a whole bale in here and let the thing go. We might need more of a chute on here. We've got the display chute on today so that we can show the machine.
It's the sneeze guard for, the cows.
Yeah, that's kind of that's one of the very interesting parts of this is the blower. So there's this feeder, and this breaks it up. Got a drawer here. So that you can choose how much insulation goes into this bottom part, which they're rubber, they're welded metal pads with rubber, and we had to roll this. You see this bottom tube is steel, heavier gauge than probably what we should have done, but we used the roller to manually roll that. And then there's this output tube here. It'll be at the edge, so we can put we've got 100 feet of 3-inch hose to basically run into the wall. And then we've got an input side back here too, so that the bottom channel of that 6-way is basically gets blown through. So there's kind of a Gatling gun of insulation that's running.
So the idea of this thing is the top just takes the compressed bale and rips it apart. And then as the little chunks fall down, they drop into this lower 6-way divided chamber, and then there's air blowing through it. And that prevents the air from blowing upwards, but allows the air to take in insulation, blow it through the machine. And then you get like little, almost like bullets of insulation flying through the tube, so that it doesn't get clogged. So if you just drop all the insulation in the tube, it would just get stuck, and then it wouldn't go anywhere.
Is the blower in here?
That's the theory of it anyway, so we'll see in practice soon here.
Where did you build that Gatling gun thing out of?
It's all fabricated from just a 1-inch shaft and metal plates, and then we cut rubber. It's all basically from scrap material from around the shop. We had some rubber that we bolted onto the paddles.
Does this violate any patents?
Not that we know of.
No, it doesn't as long as you don't sell it.
Yeah, as long as you don't sell it.
You're obviously you can clone anything you want as long as you make one of them and you use it yourself. For any that goes for any patent on anything.
You got a lot of miles on it?
What's that?
Is that a lot of miles on it?
No, we haven't. We still haven't finished it yet. To be honest, we have to do the back side of the chute, and we have to get a blower too. But we're very close now. It's been a project in learning. I think the 4 times we came in where it's like this 4-hour session's been. We're gonna like finish it up. It's like no, all this fabricating this stuff from scratch like takes time. It's taken us time. But we've learned a bunch.
Lately, my hobby's been sending Scott the links to all the Craigslist blowers that we can find.
Yeah, that's right. Risk control.
I probably missed this, but is the plexi gonna stay so you can see how close your fingers are?
That's right, yeah. It's actually
So you can see where your fingers went?
It's polycarbonate, so it should be strong enough. And it's kind of a feature in a way. We're using some scrap material we got, I think, from Tormach, had some extra pieces didn't work for them. So yeah, it'll be interesting to see the mixing and stuff as it goes.
You guys gonna spin it?
Yeah. I promised last month a mind-blowing demonstration. So you can do that.
On insulation.
This is Luke's second big welding project, so I think pretty much all the welding I'm doing this year. So so if any of the panels come fly.
It's polycarbonate.
It is polycarbonate, yeah, so. Just don't put your fingers, you know, on that side of it. Yeah, so that's the installation board.
So is the motor a three-phase motor and you're using a VF drive for it?
Yes. And it was a metric motor, and all of the shafts and the pulleys were not metric. So that was, and then we had to adapt that. We had to cut keyways in all the shafts, so that was kind of a good learning experience. And yeah, so we're using a VFD to drive.
It's about 2 horse.
Horse and a half.
To drive?
Can't be any bigger than a horse and a half because that's the VFD you've got. I need a horse and a half motor. So that's a Tormach spindle motor off their CNC or off the lathe. I forget which one that is. And then I think it's off the mill. And then the VFDs, their very oldest version of VFDs, they gave us a huge pile a long time ago. So we use them on all sorts of things. So what's cool is it runs from 120 and turns into 230 three-phase. So you actually plug that into single phase and it's generated three-phase through the VFD to run the motor, which is pretty cool.
So is Tormach going to make you put a sticker on it?
Well, I think we definitely should. Yeah.
They'll probably be willing to pay handsomely to not have a sticker.
For warranty questions, contact Tormach.
That'd be a good plan though, to pay for the other side of the metal. We could,
So is VFD variable frequency drive?
Yeah, that's right.
Ding, ding, ding.
Okay. So I just wonder whether when you speak in acronyms like that, it's like if you can't guess it, then you don't need to know.
You guessed it, Davey.
Or you should have working on it, right?
I just wish people would explain when they speak jargon.
There may be all sorts of interesting applications once we get the insulation along. I don't know what else exactly.
I've seen a really nice sausage maker.
So the VFD was the gray box on the side that was taken off another piece of equipment?
The box came from somewhere else. The thing inside the box came from something else.
The VFD is just this, it's basically got a big capacitor because it takes the 120 in and in essence rectifies it and changes the frequency to drive it. And this one is okay.
We're willing to give a really
where'd
good
you get the
discount for
board?
houses within 100 feet.
That board is a Tormach old version of their
Okay.
Yeah, question.
What does the red button do?
That is the emergency stop. So
Don't seem to be
That is
here
the
enough
only
of
thing
those.
to code on that entire.
I mean, you can't have a dangerous machine, so you need to have an emergency stop button.
Does it work?
Well, let's try it out. I'm pretty sure it works. It actually is interesting because if you flip the machine off, it instantly stops. But if you hit the e-stop, it coasts to a stop. So, yeah.
Interesting.
So the VFD supports braking, so that's why it's able to stop instantly. But if you yank the VFD power,
There's no power,
takes it
yeah, it
down.
just has a little bit of inertia.
Any other questions, David?
The fingers that tear up the bail do not seem to have the profile of the teeth that I saw in the video. Is that
The bottom ones pretty much do. The top ones, we have a couple of holes where they have a rubber flap on them. And so if it's not
my feeling is that bail may just bounce up there. If, as the teeth hit it, it might just knock it up in the air instead of grabbing it and pulling it down.
Find out.
Being the
That's
one
what
who
rubber
ran
band
the
does.
thing.
Yeah, all right.
But speaking of that, this is gonna be a much taller beast as well as the rental. So we're gonna have to grow some people to run this.
Well, if we get 3 more feet of chute on there, you just have to toss it in. It doesn't matter if it takes
Oh,
up,
okay.
but that's kind of a feature too.
So instead of one guy standing there putting a bale in, we just load 8 bales in.
That's right.
We're good to go.
So the interesting thing is the professional ones, that's what they do. They actually have a really tall hopper. And then that person goes in the house, and there's a remote switch. So you hit the switch and it starts running. And then they insulate, they shut it off, move to the next cavity and run it until they run out of bales, and they go back out and reload it. So it's not an uncommon
One-person operation.
Yeah. So yeah, this whole thing was figured out from the.
So this is a slightly different model. Actually, the video is different than the one we modeled after. Very similar, but you can see that the top layer is basically just bars with a rubber flat on it.
The blower you haven't outfitted for this yet, is it a multi-stage blower?
Well, Chris has promised a blower, so
We've got one. We've got one.
all right.
So Casey's family's company makes these dog blow dryers, which is the same thing that powers our donation tube at the front door. And so we're just going to use one of those. We're not going to integrate a blower into it. We'd rather use an external blower. It'd be a lot easier.
Because you can use that with other stuff.
We could. We could dry dogs with it, in fact. Or you could shred the dog first and then dry it. Oh, the cows were okay with the dog as well? Alright, come on now. We're going to be PC.
All right. Any other questions?
Throw pigs in there and you get sausage.
No one's gonna ask us why. I mean, why not rent one?
Say you guys are so good.
Why would somebody ask me that?
Yeah,
But
exactly.
it costs money.
Yeah.
Because your time is free, that's why.
That's why. Yeah. No, it's been a great learning project.
Did you guys get a grant for it?
We did not get a grant.
I mean, if it's
No
a good
class
project,
credit,
then
part-time.
you
I'll
know,
minimum
you
wage
get
job.
it.
How about a GoFundMe?
So
If it works, you're gonna rent it out after you're done and make it
Yeah, if you
money.
need to blow some insulation.
I was just gonna say, we're done paying the product liability insurance. We won't have anything.
What's that?
I said, I feel like I've gotten dumber grants, so I think.
Yeah. The wall, you know, the upstairs, we're almost through winter now, thankfully, a relatively mild one. But the upstairs will be well insulated, and the shops will be noise insulated after we get done.
Thank you, guys. All right, we got Dennis, and I think we got David, and that's it.
How do you run this thing?
Yep. I've been trying to alternate between big things and small things. You guys figuring this out? Yeah, that's a strategy.
Where's the cursor?
There it is. The subtitle of Sector67.
The educational benefit of rabbit holes. So where this started, there's the arrow keys. Wanted to make a thing. This is Jonathan Colton. He's a musician, kind of a geek folk kind of thing. He got on the map with a song called Code Monkey. That's where we heard of him. And we went to a few concerts here in Madison. And a number of years ago, he decided he was going to get himself and a bunch of his friends together and jump on a cruise. And they called it Joko Cruise. There's like 300 people on the first one and like 400 people on the next one. And they kept getting bigger and bigger. And a few years ago, they got big enough they chartered the entire boat. So it's just a whole bunch of nerds on a boat. And I talked my wife into going on this with me last year. It was a lot of fun. And one of the things they have is a gift exchange, sort of informally organized by one of the other passengers called Sea Monkey Mail. And you sign up to be on one or more teams of 8 people. So you exchange gifts with 7 or 14 or 21 if you're on 3 teams. And she did it last year and got some really cool stuff. And I said, I'm going to do that. So I signed up to be on 2 teams for Sea Monkey Mail. And then as the months went by, I thought, I need to figure out what I'm going to make. And so Jonathan plays a whole bunch of songs on a bunch of different instruments, but he plays this one particular song using this controller called a Zen drum. And it's a pretty bizarre song. If you've ever seen him play it, it's kind of amazingly funny. But he has a bunch of different musical instruments and voice phrases and other things controlled by this Zen drum MIDI controller. It's like a $1,500 MIDI controller going into a $1,500 laptop to do this. And I thought, hey, let's make one of those, except small. And so phase 1 was figuring out how to do this with electronics. SparkFun and I think Adafruit each have a little sound board you can hook some switches up to, you can put some MP3 files on it, and you can hit a button and it makes a sound. I had that breadboard working like in a weekend, and I thought, this is awesome, I'll just do this. But then I realized the way he uses this, there's multiple sounds playing at once, there's sounds that stop other sounds before they play, and there's just a whole bunch of things going on audio-wise that little soundboard wouldn't do. It still would have been a successful little single-layer PCB fun thing, but I decided I'm going to learn something. I'm going to jump down some rabbit holes and see what's at the bottom of them and hopefully learn something along the way. So I talked to a bunch of people and talked to Kyle, and Kyle said, hey, there's this little, because I'm an Arduino guy. In fact, I have a confession. This might be the first project I've ever presented here that doesn't use RGB addressable LEDs. I'm sorry. But I use Arduinos a lot for that. And Kyle said, there's this board, it's small like an Arduino called a Teensy, but it's like dozens of times faster. It has a complete audio library. You can like mix sounds. You can have envelopes and stuff going on. And I'm like, that sounds like just the thing. So I bought one of those. I breadboarded it up. And bonus feature, it actually also supports touch inputs. So instead of having physical push buttons, I could actually do touchpads, which I've never done before. So I thought that would be fun to learn. So I started brainstorming, and I'm a big fan of paper prototyping, so I got some old mini wheat boxes and cut them up into little things about this size, and went through a couple of those, and then decided to come over here and laser cut it out of acrylic, which is the same thickness as a printed circuit board, because I decided I had seen some structural things made out of printed circuit boards, and I wanted to do something like that. The challenge was most of those are 90-degree angles, and pretty easy to do the math on those, but these are actually, there's no 90 degrees in this at all. It's actually a wedge carved out of a polygon. So geometrically, it was a bit of a challenge. I also found out you shouldn't use CA glue on acrylic. It turns white. But I built the first prototype and quickly learned that all the electronics don't actually really fit inside that one. So I had to rev it. Fortunately, it was a parametric model, so I just had to change a few numbers. Oh, I left out the, I didn't have all these components yet, so I got the dimensions from the internet and made those out of cardboard too, so I was doing a lot of cardboard shapes and fitting them all in there, realizing they weren't going to fit. So the next challenge was how to go from the paper model to the 3D model, and I've been using OpenSCAD, which is a script-based solid modeling program for making geometric designs. But I've used it for pretty simple things like boxes with like offsets and things like that. And this has like no right angles. So I had to learn how to do that. And the first step was to just make the polyhedron, which represents the inner volume of that. But then the second step was to take those faces and extrude them 1.6 millimeters into a printed circuit board. And then the super challenging part was to actually make those printed circuit boards fit together like fingers. And you may have seen some of Jim's really cool acrylic sculptures that all fit together. So Jim helped me out and we talked about fingers, and I got some inspiration on how to do those. And so I ended up rabbit holing real deep on OpenSCAD and learning things that I never knew about in this. I'm used to programs that you write and the computer executes, but OpenSCAD is actually declarative. It doesn't actually execute your code. It compiles your code, and the end result isn't a program, it's a 3D model. And so I could figure out how to get the polyhedron, and then you had to figure out how to get the faces and the edges and the normals and the angles and the fingers, all of that declaratively with no like loops that run or anything. It does have a loop syntax, but it's actually just a way of exploding out multiple objects sort of in parallel. So that was a real interesting educational challenge. I think you're getting the theme here. All the rabbit holes are actually, you learn something in the end.
Why did you choose such an incredible, difficult shape?
That was part of the challenge. The original thought was just a single layer PCB with some electronics on and some switches, and it would make some noise. But once I got deeper into it, and I realized there's the Teensy, there's a battery charger, there's an amplifier, there's a speaker, like fitting on that on just a single layer PCB didn't really make sense to me. So I wanted an enclosure for it, and I was thinking 3D printed enclosures and things like that. And during all of the research, I ran across some sites where people were doing structural printed circuit boards, like actually using printed circuit boards that fit into each other to make a structure. So that really appealed to me, and I just wanted to go down that road.
unique in the original shape. Though.
Yeah, yeah.
Came up with it.
It's based on the Zen drum, but not. I don't have the CAD model for that or anything, so I just kind of looked at pictures of it and did it. So there's the polyhedra. Took a while to figure out how to get that in OpenSCAD, and then took a while to figure out how to extrude those into PCBs and add the fingers and tabs to them. But then once it's in OpenSCAD, it is fully parametric, and to go from this design that the parts didn't fit into to the next design that the parts did fit into was just changing some numbers, and then ta-da, that one pops out the other side. And then the other really cool thing is then you can take those surfaces or the faces and fold them out to be flat. And, oh, sorry, I forgot. There was another rabbit hole, which is when you fit things together at a 90 degree, the fingers should actually be the thickness of the board. But when you start going to an acute angle or an obtuse angle, those all change. So I did a deep dive on a bunch of trigonometry to figure out a formula that says if the angle between these two boards is, theta, here's how big the finger needs to be. And in some cases, too, there's a retraction, too. So there's two outputs of that. But the other benefit of OpenSCAD, once you fold all these out, you can actually get a 2D DXF file, which is the outline of your boards, and you can bring that right into your PCB design software for the cut path of the outline of the board. And then while we're at it, I figured I'm going to need something to build all of this onto. So by subtracting that model from a solid, I've made a little build fixture that the boards can be tucked into in order to solder them together. So as I mentioned, the first unit, I originally thought the things might fit, but then once I figured out that you actually need some 90-degree headers on the Teensy and on the battery charger and on the amp, that definitely didn't fit. So we revved it into the second prototype, and that one, actually, all the components did fit. They're just laying in there right there. The next question was the buttons on the front, so I went through a few more little paper iterations of actual size, trying to figure out how I wanted the buttons to look. Ultimately decided on that one, and then printed those out and actually tucked them into the prototype to get an idea of if, will you be able to play this even if you have fat fingers like me. Worked out pretty well. Teensy has 12 touch inputs. I used every one of them. So now the next step is creating these printed circuit boards. I have not done printed circuit boards since I had a Macintosh with a 9-inch black and white screen, to give you an idea how long ago that was. And it was all through-hole technology. Things have obviously changed a lot since then. Everything is surface mount. Didn't know anything about that. Never used this tool. Looked at a couple others, talked to Kyle, decided on KiCad, I'm not sure which name is correct. They call it both. It has a schematic capture portion where you put in what your circuit is going to be. You can create any symbols for parts that are missing, and because I was treating the Teensy as a module and not the circuitry on the Teensy, I had to create a symbol for that. You create a footprint, which is what the physical pads on a PCB are going to look like, and then you go in and do your PCB layout. And then I also had to learn about copper pores, which I never knew about before, which is usually on a 2-layer board. All of the unused space you'll fill with copper, which becomes your ground, usually on one side. Sometimes on the other side, it's your positive. On a multi-layer board, those might be, are they in the middle or are they on the outside? I don't know. Middle? So I thought that would be really useful, especially with these touchpads, because they're capacitive, and so having a ground near them actually kind of helps the sensor, I think. So, I don't know. Oh, that's way more visible there than it is here. There's the schematic. The Teensy is the big block at the top. On the left is an Adafruit battery charger that takes 5 volts from a USB in and takes care of all the battery management for a lithium polymer battery. And then the bottom thing is the amplifier. It takes in a low-level output of the Teensy, which is from an onboard digital analog converter, and is a 2.5 watt mono amplifier that drives the speaker. And then I wasn't sure if all of my sounds would fit on board the Teensy. At the lowest quality level, you could fit just over 20 seconds of audio on there, and I wasn't sure if I could jam into that or not. So I actually designed it to have a SPI serial external flash chip for an extra amount of memory on there. So I would have like a minute worth of audio or 2 minutes. In the end, that actually turned out to not work out so well because of space constraints. So I ended up compressing all of the sounds or chopping them down enough to fit into 20.5 seconds. This is what the PC board design looked like in KiCad. You can see there's like red for one side of the board, green for the other side of the board. The weird boxes around the pieces declare these copper pore areas, which creates the big filled in red area. And there's this really cool 3D view feature in there too, which is, I found pretty amazing, because you could like look at your board as if it was real. And if your symbols actually have 3D models on them, like the power switch and the resistor, it shows what those will look like on there too. I found that fascinating. I've played around with that a lot. But the final output that you really want are called Gerbers, which is actually a file format that goes back to like the 70s, I think, that all of the board houses take in order to manufacture your PC boards. So here's the Gerbers for the front or the top of the board and the bottom of the board. The guts of it are all the inside, the top, and the touch buttons are all on the outside or the bottom. And once you have those, you can send them off to a board house to have boards made. So one of the cool places Kyle turned me on to is like PCBshopper.com. You can put in your board dimensions and other specifications like layers and things, and it'll go off and get it quoted at all these awesome board houses around the world. Turns out most of them are in China. And beginning of 2020, ordering boards from China is actually not such a great idea in terms of getting them back in time. Most of the board houses were running at partial capacity, and not all the colors, and like a lot of other issues. And so I had no assurances I was going to get these back from China in time. So I just ended up paying almost double to go to a US board house. But I had the assurance from another person that they could deal with strange shaped boards like this, which a lot of other board houses, they only want to see rectangles. They don't want to see anything fancy. So knowing with the assurances that they could deal with it, and knowing that it was going to turn around in the US, I went with Osh Park, which has the added benefit of making boards in my favorite color, which is purple. And so this, when you upload your Gerbers, or they'll actually take a KiCad project, which I think I sent them, they have an online visualizer that actually shows you about what your board is going to look like, which is also kind of exciting, like the 3D view. So that's what the top is going to look like, and that's what the bottom is going to look like. I don't know if you can see the circles for the touchpads on there. So sent that off, and then you twiddle your thumbs for a while, or actually should have been working on the software, but I twiddled my thumbs for a while. And then you get some email alerts telling you that it's been panelized and sent off for manufacturing and then shipping, and then it shows up at your house, and boom! Oh, wow, that didn't look like that picture at all. It's panelized into a rectangular board. They've created little tabs, and so all these pieces, instead of just like sitting in a bin for you to solder together, suddenly you have a new job in front of you, which is cracking all of these out of the boards and then filing them, because the fingers don't work if you have all these little extra bits on there. So that was a whole afternoon filing fiberglass with a mask on, which was fun. But there's the filed pieces laying out. These are real ones, not just simulated pictures online. And then here they are put into the 3D printed fixture and then soldered. So using solder as a mechanical structural thing rather than as a conductive thing. And then I decided to show them off a little bit and actually put an acrylic cover on the back so you can see the guts on the inside. And then there's what it looks like on the outside. You can see the touchpads. I later covered those up with some printed vinyl stickers that look like buttons. And then soldered in the first batch of electronics. After thinking about it for a while and talking to Kyle, I decided to surface mount the Teensy by putting 90-degree headers on it. So essentially the pins come down and then out. And those copper pads you saw here are where those pins lie. And then you just, get them hot, wick in the solder, and then you're all set. So instead of through hole, it's kind of pseudo surface mount using headers. This one does show that SPI flash chip populated. It turned out that the stack up between that, the battery, and the speaker was too tall. So I had to go back to the drawing board and make sure all the sounds would fit, and then I axed the chip and didn't populate that on any of them. There's also a little tiny slide switch right down there. So that's the first one all the electronics went into, and it worked. Yay. So as a software person, like you're done, right? You just run that batch file 20 more times. But as a hardware project, oh my God, like if it takes 5 minutes to put that together, that's an hour when you have 20 of them. And it didn't take 5 minutes, it took more like an hour. So that took like a whole week to put these things together. It's insane. And that's just, I don't get how people make 200 of anything in the world. So you got to take a break every now and then, artistically arrange them and take some pictures. And then design the fancy acrylic cover that's going to go on there. My wife made me a cool logo that goes on there. And I decided I might as well tell them which way to attach the USB cable. I also decided this was art, so I serialized them, 1 of 20 all the way up to 20 of 20. The software relied on the Teensy. They have an environment called Teensy Arduino, which layers on top of the Arduino IDE that supports all of their boards. And then they have this really fantastic Teensy audio library that allows multiple sound sources, mixing, retriggering, looping. That's probably all I used, but if you wanted to, it has synthesizers and envelopes and mixers and just crazy filters and all kinds of fun things like that. There's just a snippet of the code. This one says, and then I also used a touch library somebody made that handles all of the analog nuances of the touch inputs and basically gives you digital, nice, if statement kind of things out the other side. So you could say, if touch 4 rising edge, sound 1 play, audio sample symbol, done. So now when you just touch your finger, that symbol plays. You can also do some conditional things. I have a couple Easter eggs hidden in there using some conditionals. And then in this case, it's a loop. So once I've started this playing, I set a Boolean true. And if that Boolean is still true and the sound is not playing, I retrigger it. So it'll play, as soon as it ends, it notices it ends and it starts it again. So that's a fraction of a millisecond, so you don't really hear a glitch there. I'm sure you could if you listen. So this includes the vinyl cut stickers for the buttons, and then a big hat tip and a thank you, Kyle, for the PCB inspiration, and Teensy, Jim for the fingers and interlocking things, Chris for the help lasering and just having Sector67 in general. Some of you remember Robin Lawson of Lumen Jewelry. She's done a lot of non-rectangular PCBs back when it was super hard finding a board house that would do them for you. There's also this hacker in Switzerland. She has a blog called Pam's Hacks, and she has some really great non-rectangular PCB things on there and a video showing how she does them. Sean Himmel of DigiKey has some great KeyCAD videos, as does Chris Gamble of a contextual electronics blog. Paul Stoffergen did Teensy and the Teensy audio library. My wife did the logo design, some design input on the shape, and did some fantastic packaging, and of course putting up with me. And here's what the end result looks like. This is what my anonymous gift recipients will get as a little lanyard music player. You turn the switch on, and you can be like, it's a little quiet, I don't know if you can hear it back there, but it's doing a guitar loop there. That's one of the looping ones then. You got some cymbals and drums over here, and then some phrases from the song over here, including the most famous one, which is dance. If you've ever heard the song, you would know. So he's got a few things where he'll cut up the words from different parts of the song. I guess. It's got a couple Easter eggs built in. Mario theme. So, I've left one on. The battery seems to last for enough time. I clocked it at, I think it was 6 hours. Since then, I found some tips online on how to cut your power usage by lowering the clock frequency and a bunch of other things like that. So I'm hoping that'll actually run for more than 6. So that's my gift exchange thing. Any questions?
Wow, I sure hope you don't get bumped from the cruise.
I know, right? Like, how do you think my life has been leading up to this thing that we committed to like a year ago? And then January comes and February, and like, I've had a conference I'm going to canceled. The GDC's been canceled, GTC's been canceled. I don't know what. One of their own boats got turned away from some ports for a while. So yeah, if you don't hear from me, I'm in the Caribbean somewhere, like maroon. Yeah, being quarantined. But which sounds like so much fun, but you actually just get locked in your room, and that's not so much fun. But yeah, there's concerts every night on the boat, and gaming and food.
So I've used that OpenSCAD.
Yeah.
And I misused it too. I used it to design wiring layout for a room, to place a panel and to run conduit.
Wow.
It can be done, but just because it can be done, don't mean you're supposed to do that. So I'm thinking there must be some 3D CAD where you can actually do subtractions and fairly quickly come
Yep.
back. Right?
Yep. And that the 3D view of the PC boards, the little picture you saw of that switch and the resistor, a lot of people model those using a CAD program called FreeCAD. And that's more of your traditional graphic, click, drag, pick a color, very interactive graphical CAD program. I think for me, the appeal of OpenSCAD in this application was that I did know I wanted a parametric model, and I did know that I wanted to generate the edges, not have to draw the edges. I wanted to write code that made the edges, and OpenSCAD's the way to do it. When it comes to writing code to make geometry, that's the path to take. And also knowing that I wanted to fold them out into flat shapes and things like that. So I think there is plugins for more typical CAD programs that'll take a 3D polyhedra and unwrap it into flat shapes, but in this case, I didn't know how to script them to make the weird fingers around the edge. So, and that actually changed. In prototype 1, I made 8, or I guess 4 in, 4 out fingers per edge, but once it was done and talking to Chris and Jim, they're like, that's way too many. So in the end, I ended up with 2 out and 2 in, so half as many, and it holds together just fine. This is one of the boxes that's only soldered, and sometimes they didn't solder up quite right. I had a few extra that didn't fit, but that's what it looks like with the cover. You can pass that around. I don't know, I've always been fascinated with the hacker cons all have digital badges that communicate with each other, like that Ponagachi, and I just like the concept of doing weird things with printed circuit boards. Surprisingly, there was no LEDs involved in this. If I had more time, there would be.
Not even one?
No, well, the TNC itself has one that you could blink, but it's going to use a little bit of current, so I didn't even turn it on. The temp was there, but I am literally down to the wire on this. We leave on Thursday, so I just finished this weekend. I call that good time management. My wife calls it waiting way too far to finish the project. So these got sent off to OSH Park January 30th, and the boards arrived on Valentine's Day. So it's been a crunch, and there's other projects to work on too. She had her own things she's working on, so we're competing for the vinyl cutter. And it's a lot of fun.
All right, thank you, Dennis. David, you're up. It's a characteristically short presentation, right?
I have decided to divide it into 2 7-minute presentations. That way I won't run over. I would like to slow the pace a little bit. But could I have some help with my presentation?
Yeah, what's up?
Where do I put this in?
Just fold it up and put it in the SD card slot.
He told me I might not be able to, so I brought a more modern. Seriously.
Did you 3D print the same icon?
Oh, now with all that, he can't find his stuff.
I can't even find the thumb drive now. This is not funny.
Well, you better be prepared for your live demo.
All
I
right.
think we do have a 3.5-inch floppy drive reader somewhere for files that let you
Oh, wait. Wait a minute. No, that's not it. 5 1/4 inch. This is so typical. All right, we'll just do it the hard way. I'd like to pass this around. The point is, I'm going to be doing some glue ups. for some cutting boards. And I just don't like dealing with those bar clamps in the back. You gotta take one, you know, a set of them, lay them down, if they'll stand, if they will lay flat, and put them on the floor, then set the other ones on, set your boards on top. Then you have to interleave another set of them in between them, so we want half of them coming up, half of them coming down, because as you tighten bar clamps, what we're talking about here is a set of relatively thin boards that you're trying to glue together on their edges. When you pull them together, well, you can sort of imagine you put a clamp across, tighten it really tight, what happens is sproing, they all pop up. So to compensate for that, you put another set of clamps opposite to those and tighten them simultaneously, so some are popping up, some are popping down. It works just fine. But somebody a few years ago invented these that's the word.
Four-way clamps.
They're four-way clamps, but I'm trying to show what kind of figure they make up. They're bead, I guess. Is what they want. And what he invented was just this part. This is the working part. And then to get these cutouts here, he just took a 2x4 and just drilled a series of holes down the middle of it, and then split that, rotated them around, and then had his business pieces here to do the job. The key thing is you got a slave here, and I got an end here with a screw on it. And of course you can see that the screw is going to move this piece down toward this piece. Of course this can't go anywhere, so this is obviously going to clamp something in here. But at the same time, the simultaneous action is that as I clamp this down, these two pieces are pulling these two boards together. And there's your what is called a caul in the caul is an extra clamp you throw on to a panel to compensate for that bowing, to counteract the bowing. So in this case, it was a great idea, but they weren't selling these because nobody wants to drill a bunch of holes, let alone run a thing through a table saw to split it. So then some other genius came up with the idea, well, let's just make the holes for them. And that way we'll save them having to drill a bunch of holes down the middle of the board. Instead, we'll just make them drill a bunch of holes down the sides. You can't see it here, but each one of these pieces takes 3 wood screws. And to make it flexible, I mean, not everyone is going to use this width. Somebody's going to have a piece and they're going to want to use a piece of the width down here, and oh, it won't reach that far. You can see there's some play in this where you can get some adjustment out of it for most of your work. But if somebody comes in with an extraordinarily long project, well, then we'll want to take these loose and move them. And I've already conveniently drilled those holes out for you for when you want to do it. Now, my idea with this was I don't even want to deal with these. I mean, I still don't want to be messing around with these things. My idea was, that's not supposed to happen. Somebody's going to get pinched. Okay, another fine demonstration brought to you by David Nelson. My idea was that take an existing clamp rack back there that's not doing anything except holding clamps while they're sleeping, and run a bar, a rod across the top of it. I was going to say drill a hole in this, but use a conduit clamp on the back side of it to just grab that rod that goes across. So now this thing will just rotate on that. And then put 3 more on there, him and 3 brothers on there. So you have a set of 4 on there, and now they're hanging. And I have this piece at the top, and I have this piece at the bottom. This is going to hurt. And they'll all be standing out like this, and I can just come along and lay my boards in there. And then come one at a time and slip this piece in. This is the part that's theoretical. This, you know, I'm going to slip this in, and then slip it in the bottom here, and do that for all four, and then go along and tighten them up. And then when they're done, my whole panel just hangs out of the way. I can go on to something else. It's not covering a table, it's not covering the floor, it's hanging up on the rack. So I got this far. I've been watching these things for some time, and the price finally came down to within reason. And I got a set of 4 pairs and made up a set of 4 of these. So we have those, and then I ran out of gas. I don't want to hang them or anything. I want to see if they work before we do any of that. I will say that the 4-way clamp is a lie, right? It's really only clamping 2 directions. It's clamping this way and this way. It's not.
That's the reaction force.
Yeah, yep.
That's the 4-way way.
There you go.
Bullshit. But, so, just saying these things are available. I will say one last thing. There was, gosh, the slickest slide of all that I had was awesome. I mean, I spent easily an hour on my presentation. The greatest, you wouldn't even believe it. The last one was showing you how to mask these things with blue masking tape. I mean, it was a work of art.
You can email it out, David.
I'm pretty sure that it's lost. I'm pretty sure it's lost. In fact, if I find it, I'm fairly certain the digital file is damaged. I'm sure. Beyond repair. Just use your imaginations, and it's better than that.
One that got away.
They're there. If you want to use them, you're welcome to it, but I would ask you to just put masking tape on this, and everybody does this because when you tighten it down, the glue has to go somewhere, and it comes out, and it craps up your clamps.
Anybody got any questions for Mr. David?
I'd be amazed. It's so simple.
How much do they cost?
They're free because they're at Sector 67.
How big are they?
If you wanted to do these at home, they're about, if you buy them in a quantity of 4, you can get them for right at $100.
You mean like cutting boards or countertops?
Cutting board.
Those seem like excessively big.
Oh, well, what you want to do is you want to do glue up. Your sticks come long.
Oh, right.
So I don't want to cut the sticks and then glue them. I'm going to glue them and then cut them. Because, like JD said, the order in which you do things can really make a difference.
Any other questions?
No, they only come in black, Mark.
Have you used those, and is that part of the presentation?
I think Dave's going to do a demo after the meeting. Aren't
No.
you, David? You going to do a demo after the meeting?
No.
No.
David's trying to sucker somebody to test these for him, I think.
Yeah, that's the idea. Somebody please test them.
Is there, I don't even know the correct term to use because I don't do wood, but is there a ratio of, like, these seem like they're creating a lot of side force for the glue up and then less compression force to prevent the bending. Is there a common ratio in that?
No.
You just enough that it doesn't bend, right?
Again, this is, yeah, it's really relying on the stiffness of these. These should be hardwood. The original ones that I made, again, before the screws, I had cannibalized some unistrut upstairs, what's for hanging stuff on the ceiling. And the sweetness about that is You know, you want this, you want this to be a ½ inch over, you just loosen the unistrut nuts, move it over, and tighten it back down, and you've got infinite variability there. So I showed Chris the prototype and said, okay, where's the rest of that unistrut? Because I'm looking for a 10-foot string. I'm going to make 10-foot long versions of these things, you know, and blue and steel should be a little stiffer than pine. And it turns out the unistrut wasn't the problem. We don't have a lot of unistrut left over, not long pieces. But I went to look at that. Well, they won't sell it to you for less than 10-foot sticks. I don't need 100 feet of it, but that's all I can buy. But that turns out to be, that's the cheap part. The unistrut nuts are like, I don't know, $25 each. I mean, that was the feeling I got. That was like 12 for $25. What? You know, and so I would have needed 12 per. There's 48 I need. That was ridiculous. What people do when they make calls in real woodworking, you make these actually, you're supposed to go in and put a very slight radius on this. And there's your compensation on both sides. So now as you pinch these ends together, yes, you lose force in the middle, but you're actually building it back up because it's thicker in the middle than it is on the ends. And that's what they've been doing that for 500 years. I regret that the technology at Sector 67 has failed so miserably.
Thanks everybody for coming. If you guys want to go around and see who you are, what you're interested in, or whatever else, we'll make Dave go last. Guy, want to go first?
Yeah, Scott, I'm a member here, and lately been working on the big wood router at the wood shop and the installation blower.
I'm Sarah, I'm an industrial engineer. I'm not really working on anything right now, to be honest with you. I'm just working a lot.
Owning a house counts as working on something.
Is it? When it's brand new?
Especially.
Yeah, my name is Mark, sort of on again, off again member. Mostly making airplane parts lately.
What kind of airplane?
I have a Vans RV6. It's like a kit plane.
Yeah, that's awesome.
Is that a like sit-in plane?
Yeah. It even has a big fan on the front, so you keep it cool.
My name's Dustin. New here. I'm an EE. I don't know. Yes, I make a lot of video game and movie props, TV shows, things you see on screen.
I remember you bought several Ghostbusters packs, as many different versions of Ghostbusters packs.
Ghostbusters packs, Halo Sword, really, really cool things I've done.
I'm Joe, I like 3D printing. I've been doing a lot of surface mount soldering lately. Smaller and smaller, no microscope, but
You're crazy.
Kyle, I'm an electrical engineer. I'm usually just playing around with the application. Josh, I'm also an electrical engineer. Working on some electric vehicle projects and like playing with LEDs.
Me, Dennis? I usually work with LEDs. This is my first sound project.
I'm Doug. I'm just came here today to check this place out. I've seen some stuff on the internet, so I can hopefully take a tour too after this.
I'm Mark, I'm a member here. I'm Bob, electrical engineer. I do a lot of consumer electronics, IoT stuff.
Diego Gao, photographer, entrepreneur, thinker.
I'm Jaden. I learned stuff. That's what I've been doing. All kinds of things.
I'm Chuck. I'm a volunteer for the Wisconsin Science Museum. I build exhibits.
I'm Ryan. Oh, sorry. I'm Ryan. I'm a pen tester. I'm a newer member here, but I've done some of the Dave, I think we put that garage door together, right?
Yeah, we did.
So I've done a little bit of volunteering here.
It's still up.
I saw it was crooked though. So.
Yeah, and apparently somebody got it down too.
Yeah. So, yeah. So yeah, and I did some of the drywall too. People have fixed those holes too. So yeah, I'm glad to finally be a member here. So nice to meet everyone.
Jeremy, use your Raspberry Pi.
I'm Brendan. I'm working on a 1979 Kawasaki motorcycle right now.
Sean, looking forward to help Scott test run his new creation with some of those pallet racks upstairs that we have.
Jim? Jim, I'm in the electrician apprentice program. Currently assembling outlets. Wrong. Careful when you plug stuff in.
I'm Davi, software developer, just trying to keep up with my job these days. I'm a member here.
I'm Joe, I'm a member here, I've been tuning with an 81 Mirage lately.
Chris, the software developer, I just bought a whole bunch of aluminum tubing, and so I'm trying to put together like a Yagi antenna, 6 meters.
I'm Alina. I am interested in becoming a member potentially, much to my father's eternal disappointment. I'm not an electrical engineer. So I'm interested mostly in woodworking. Although I would like to build an electronic pedal assist airplane.
Yes.
Because I
This
feel
is the
like
right place for
that's
it.
never been done, and I think that if you had like a 6-to-1 ratio and you could pedal 200 watts, so 12, you could probably get it to fly. You'd have to be lighter than me, but we could find somebody kind of crazy and skinny. And well, it's not been done with an electronic assist though, and those things only fly at an extremely low altitude with big ground effects. So to get it out of ground effect and actually maneuvering would be a frontier in flight that's not been accomplished.
Sounds like a perfect first woodworking class.
I think that makes sense.
Maybe some others.
Yeah.
Guys in the middle.
Yep.
My name's Nick Hine. I've been a member for about a year. I'm taking off this month to go out of the country for a few weeks, but I've just started making, trained as an aerospace engineer and airplane designer, aerospace design engineer, and yeah, I got some experience in puzzle stuff. What are you talking? I just started working on a queen size bed that I'm making from white pine that was cut on an 80-year-old tree that was planted by my grandfather.
I'm Tom, I'm a member here, but occasionally show up. But there's a machine back there in the corner that was made in China, BN 2000, HHO generator, and I'm currently reverse engineering to try to figure out.
It's an HHO generator.
Yeah, it's a magic gas that does everything from make you live longer to reduce radioactivity. All kinds of things.
There's an H2O.
It's basically electrolyzing water. But in the process of doing so, it does it with some magical mystery that we're trying to figure out. So,
can it cure the coronavirus?
It can sure as hell give it a run for its money.
I would say pretty much any torch can cure the coronavirus. Probably not every human.
So I'm David. I'm not an electrical engineer, but I have 3 degrees in the subject. I built a CNC machine to carve topo maps and wrote the code to the program. So some of my early efforts are here. If you want to see my later efforts, they're at the house under the bed. They're not any better. But we keep trying, right?
Thanks, David, for bringing the floppy disk. I think I could do about 5 1/4 though, if you give me a little time. Pull it together. Get my
Actually,
presentation off of there.
I am taking this home seriously because it has software on it that I'm going to use to upgrade my 1988 software that I'm running. It's a family history program. Never found anything better. I'm going to upgrade it to 1989. This baby right here.
Hello.
Oh, I'm an amiga.
Alright, my name's Chris. I can show you around if you like. If you come over this way somewhere, I'm happy to show the shop, or at least let's see it roughly, and if you have questions, you can talk about it. But thanks everybody for coming. David's going to give a demo on wood clamping right here, so David will be in the wood shop there doing a lot of cleanup. Thanks everybody. Right, David?
I'll glue something to that table.
Yeah.